Welcome to Lesson 6.5, Linear Inequalities, Part 1. You may notice that there's no video for Lesson 6.4. That's because 6.4 is mainly word problems. So really for that we just need a quick review, which we'll go ahead and do in this next slide. 6.5 is a lesson.
Really?
Watch this and you'll learn about graphing. Yeah, there's no video for 6.4 all word problems. We just practice it in class some more.
Right.
You should do some review like this. Remember how to use all of the methods.
Yeah.
Graphing 2, represent and estimate. Substitution solve for one variable. And now elimination, eliminate that. Make two variables the same as 0. Cancel in where it at. As an ordered pair, you should write that. I'm so mathy. You already know at least chapter 6, 6.1 through 6.4. I'm so mathy. Ready to move on. Linear inequalities. On with the video. So a linear inequality is a linear equation. So that's an equation that has two variables, usually a y and an x. But in the equation, it's going to have a inequality symbol instead of an equal sign. So remember, our inequality symbols are greater than, less than, greater than or equal to, or less than or equal to. So as we go through the problems, we will have times when we get a look and say, okay, is 1, 2, that ordered pair a solution? So in order to check this, remember we're going to go through, and ordered pairs are always written as x, y. So we're going to plug those numbers in and see if they work. Is 2, in fact, greater than 1 minus 3? Well, if we go on to solve that out, we say 2, is that greater than negative 2? Now remember, this is not an equation, so we're not saying is 2 equal to negative 2. We're saying is 2 a bigger number than negative 2? Well, one's positive, one's negative. Positive numbers are always bigger than negative numbers, so I'm going to say yes, it is a solution. Let's try another one here. Is negative 3, negative 7 a solution? So again, we have x, y, so we're going to plug those in. Is negative 7 greater than negative 3 minus 3? Now, let's remember that subtracting a positive is the same thing as adding a negative. So negative 3 plus negative 3 is going to give us negative 6. So is negative 7 in fact greater than negative 6? Remember, it gets a little confusing as we start getting more negative, but more negative means that it's a smaller number. So in this instance, this does not work and it is not a solution. Now that is only the first part of it. We're going to start graphing this lesson. Today we're only going to cover kind of the basic parts of it, but nonetheless we're graphing. So greater than or equal to or less than or equal to. Remember, the or equal to signs have the little line under it, which means or equal to. When you graph these lines, you are going to graph them with a solid line, just like we've been doing. You are going to use a solid line. When we graph equations that are less than or greater than, now remember those ones, that's greater than, that's less than, they do not have lines under them. When you graph those, an equation using that, you're going to use dashed lines like this. So remember, when we were first starting off and we were using a number line, we said, okay, if there's a line under it, we're going to use a full closed-in circle, right? And we were going to point our arrow whichever way it needed to go. Or if it was just less than or greater than, we were going to use an open circle and point whichever way we needed to go. Here it's similar to that. We're either going to use one solid line or we're going to use a dashed line. Alright, so let's move on to the actual graphing of the equations. If we look here at this equation, it looks like something we've seen before. Even though there's this inequality here, it still looks like the form y equals mx plus b. So we're still going to graph it just as if we had that equation of y equaling mx plus b. So my b, or my y-intercept, is 1, so I'll plot a point at 1. My m, or my slope, is 2. Remember, slope is rise over run, so that's like 2 over 1. So I'm going to go up 2 to the right 1, up 2 to the right 1, and I'll plot my points there. Now we need to stop acting like our inequality is an equal sign. We know that this is a less than symbol, and in the previous slide we talked about how if it's or equal to, we're going to draw a solid line. Since this is just less than, we're going to draw a dashed line through our points. If I were to just look at the graph, I could tell what my equation of the line is. I could tell that it's either less than or greater than, but I wouldn't know which one. When we have the less than or greater than, that means that all of the possible answers are either on this side, or all of the possible answers could be on this side, the numbers greater than or the numbers less than. A lot of times people say if we're doing less than, you're going to shade under the graph. If you're doing greater than, you're going to shade on top of the graph. But sometimes I don't really like that because it's sort of hard to tell. So what I like to do is I pick a point. I like the point 0, 0. It's a nice and easy point to plug into any equation. And I'm going to plug that in to my equation up here to see if it comes up with something true. If it comes up with a true statement, then I'll shade at this part here. If it comes up with a false statement, I know that 0, 0 is not one of the answers, so I'll shade in the other side. Let's try it out. Is 0 less than 2 times 0 plus 1? Is 0 less than 0 plus 1? Is 0 less than 1? Yes, it is. So that means that I'm going to shade on this side of my line. This would be your final answer to the graph. Let's go ahead and try another one. Here we have the equation y is greater than negative 2x plus 8. Again, this looks like y equals mx plus b. In this case, my b, or my y-intercept, is 8. My m, or my slope, is a negative 2 over 1, so I'm going to go down 2, right 1, down 2, right 1. It's a greater than sign, so will I have a solid line or a dashed line? If your answer was a dashed line, you would be correct. We will draw dashes through. And now let's pick a point to test out to see where I should shade. Again, 0, 0 is a great point to select. Let's try it out. Is 0 greater than negative 2 times 0 plus 8? Is 0 greater than 0 plus 8? Is 0 greater than 8? Well, definitely not. That is not true. So I'm not going to graph on that side. I will shade in on the other side of my graph. I hope that this video was helpful. Remember, you can always rewind, go back, double check the things that you need. To end, we'll go ahead and tell a little joke. What be a pirate's favorite letter? Did you say R? A lot of people would think so, but it's actually the C. Har, 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 har.